Those slides look good to people. Just verifying the share works.
Hey folks, just getting ready to go.
The Jabber room is not working, and I just sent a chat to here on Meet Echo, and nothing showed up.
I believe the IETF Jabber server is down right now.
Yeah, that might explain it.
Seems like we should use MLS instead, no?
Well, MLS doesn't create any chat functionality. It just creates another opportunity for the chat not to work.
More failure points. Lots of failure points in MLS.
No infinite regress, Sean? Come on.
Still figuring it out. Yes, I really want to share my screen. What do I want to do?
The MP3 audio stream is not working either. Not sure if that goes over the same portion of the infrastructure.
In the meantime, we need a note taker.
Just looking through the participant lists, Jonathan Lennox, Jonathan Hoyland, maybe?
My alertness at local 4 a.m. is not fabulous, but I could give it a try.
Is there anything to do if the Jabber is down?
Well, note taking is still how you have to do something.
They say they're working on the Jabber, and they'll let us know when it's up.
Yeah, the CodeMD is still up. So in terms of recording group decisions and taking notes about conversations, the note taker is still useful. So Jonathan Lennox, if you want to open it up and record the decisions, that would be fantastic.
Yeah, I've got it open.
Okay, I think I've pressed enough buttons to make this work. There's this. Is this going to go into the right thing? Are you guys seeing the slides? Yeah, okay. Brilliant.
Yeah.
All right. I think we're here. Let's do this. Welcome to the MLS meeting. It's Thursday. Hopefully you guys have seen all this stuff. Turn your video off. Mute your microphone unless you're speaking. Obviously, you've made it here at Meet Echo. I don't know if the audio is going to work, if it's only, but, and the Jabber I think is down as well. So I think we're just going to plow ahead and we'll deal with it later. Here's the note. Well, obviously we're recording the session.
Jabber is back up, Sean.
Oh, great, cool. There's the address there, mls@jabber.iatf.org. I believe that the chat in Meet Echo actually relays it to Jabber. So if anybody is in Jabberland and does like do a mic colon, please feel free to jump in and relay that for me, and Nick as well. Again, here's the note. Well, basically, put rules and policies to play along with the IETF. We're recording it. Be polite. If you know of any APR, you're supposed to disclose it. Again, it's Thursday, so hopefully you've seen this. This is us. I'm Sean Turner. Nick is here as well. Our agenda is pretty straightforward. We're going to go through some administrivia. We're going to have an architecture update. And then the rest of the time, we're going to deal with the protocol. Richard lets me know that the chances of us going to full 2 hours is somewhat minimal. So that might be good so everyone can get back in bed. So we're just basically just going to jump over. He's got some slides. I've uploaded them. And Benjamin also gave me some slides on the architecture. So we're going to go through. Status. Actually, I should jump back. I fell off. Is there a minute taker?
Yes, I'm in the Cody MD, and if anybody wants to join me,
Awesome. Thank you. Thank you very much, Jonathan. So the status, basically the architecture draft, we're going to talk about that. We're basically waiting for a new version. The MLS protocol draft, I guess technically is no longer in working group last call. It ended yesterday. And the Federation draft we had has expired, but I'm hoping that we'll get back to that after we get the protocol document kind of out of the way. So for those of you, not everyone in this working group is like immersed in the IATF, know about the process and what's going on, but I wanted to kind of outline the timeline for what's going on now. We just completed working group last call, so there's that little bubble there about we are here. The plan is that we are going to publish a draft 11, which addresses all known comments. And then we're going to have a feature freeze where we're going to let the security researchers kind of beat on things for a little bit. We haven't quite decided how long that's going to be, but I think it's going to be long enough that we can get multiple sets of researchers to actually provide us some input so they can get a kind of a warm and fuzzy that we are offering the properties that we say we are, given the right choices. I suspect they will find something, so there will be another draft, though there's draft -12 with a question mark. I'm betting they will find something, then we'll make some tweaks. If we make tweaks that are substantial enough, we need to run another working group last call. And then after that, there's probably I'm sure there's some editorial thing that'll pop out, so we'll have a draft 13. Now, the nice thing about where we get to it, if we get to a draft 13, if we've had this analysis, it makes things a lot easier for the AD and later for us when we have to deal with comments, because the document will have been reviewed by more than just the people in the working group. It's actually going to be other people, security researchers, that will make sure it's clear that the document's doing what it says it's going to do. But our AD, Ben, is going to do a review, and then whatever he tells us to make changes to, we will discuss with him. We'll make some changes, and we'll have a draft 14. And then after that, it goes into what's called the IATF last call. It'll be 2 weeks. And then, I suspect there'll probably be some other procedural things that we maybe miss. You never know. Maybe we'll get lucky and we don't need a draft 15, but a lot of times this is where you get cross-area review. So there's directorates that will kick off, like Gen Art, they'll tell us we did our IANA considerations wrong or something, and we'll fix it. And then after that, it goes to ISG review. All of the area directors from the ITF will take a review. They will find even more things, and we'll probably do another draft 16 to try to get through them. Once we're there, basically it gets approved and gets dumped into the RFC editor queue. Then there's a process at the very end of that called auth48, which is where basically it's copy editing, but sometimes they find other things. So there will be other changes that come out of the draft, come out of the process, sorry, that end up resulting in a draft. And at the end, we're going to have an RFC. The process after we get from area director review to an RFC, it's probably 3 months. So I think we're looking at, 6 to 9 months away before we could realistically get an RFC number out and be done. Are there any questions on that?
This has been KDUC, the AD. I think the 3 months from AD review to RFC might be a little optimistic. The RFC Action Center is like still dealing with this giant cluster of WebRTC stuff.
Oh, it's still doing 238?
Yeah, I mean, most of it is in auth48, but there's still some knock-on effects, basically.
All right, well, fair enough. I mean, I think it's good because basically it still gives people additional time to review things. And I mean, I think the nice thing is that we're basically following the TLS kind of pattern. And I think it's good because when we get after the feature freeze and analysis and we actually get review, chances are we'll find most of the big things. There's a chance that we can find other things that are worthwhile to change later. But at that point, the bar is pretty high. And the other people that we have to convince that we're changing and not breaking everything is also higher. So I think it's basically good. And all right, that's it. So now I guess I'm going to hand over to Richard. Or sorry, to Benjamin. So where did I put it?
I thought we were doing architecture first.
Yeah, or maybe whatever you prefer. Actually, it's fine.
No, go ahead, Benjamin, because the protocol stuff I think can expand to fill time.
Sure. Okay, let me try to show screen. Can you see that? Can you see my screen right now?
Not quite yet. I think the chairs have to allow you.
Yes.
I think I'm doing that.
It's good.
I did upload these slides as well.
Yep. It's a stupid iOS thing where you have to actually log in and stuff like this. So sorry about that. Oof. Do you have actually my slide, Sean? Maybe it's easier. There is only one slide anyway. Mission? I can't actually hear you. Can you hear me now? Yeah, I still can't hear you.
We can hear you, Benjamin.
I can hear you,
Okay,
Benjamin.
I can hear you now. Sorry. Technical things. Yeah, so okay, let me jump in now. Thank you. So the idea was that a few months back we sent an email to the mailing list saying that we are gonna do an editorial pass collectively on the architecture documents, and the timeline shifted obviously because of multiple things, COVID and the delay in the protocol document as well. The idea was like basically we could sort of go back to the architecture documents once the protocol document was stable. But I think we are in a pretty good shape to actually look at it now. So the chairs asked the editors to actually take a pass on the architecture document, which I'm doing right now, and ask for the other editors to review. The idea is that basically I want to have something stable by December 7th so that people can sort of input from that point. So I don't think there are many actual things to discuss. We are going to pretty aggressively, as Sean mentioned in the mailing list, we are pretty aggressively going to close issues and try to solve them, of course. But like allow people and encourage people to do a pass on the architectural document after December 7th. So the idea is basically we expect, I expect, depending on what the chairs think is a good idea, but I would expect that between beginning of December and end of January, we have something like everybody filling issues and reviewing, producing PRs for the document, and that we can recurse on that multiple times until we have something that's good. But I expect that the changes to the architecture document are pretty limited. It's more typically what we're interested in here is the fact that we are missing some things. Like the MLS protocol is quite big, right? It's complicated, so we definitely miss important information or insights on the protocol. And especially in the architecture document, sorry. And we want to describe very clearly the security guarantees that we expect with much more precision than we have right now. So right now we have something very generic, which is like, oh yeah, by the way, this protocol wishes to provide forward secrecy across epochs, forward secrecy for application messages, post-compromise security across epochs, things like this. But it actually depends on many things, right? It actually depends on people updating regularly, on people sharing or not sharing their identity keys. Things like this are actually left to the application for the protocol document. So the architecture at least should mention what are the pros and cons of doing such things like reusing signature keys, not reusing them, updating frequently or not updating frequently. The idea still is that we want this document not to have normative language as much as possible. So I suspect we will be able to do it, like only based on recommendations, because the core protocol document contains every requirement that's needed to provide the security guarantees that we would like to have. But people have looked at it. We have done security analysis of the protocol, and we know that depending on what you do exactly, there are some slight differences in terms of security guarantees. So we want to actually make those guarantees and expectations very precise in the architecture documents without mandating anything. In some sense, it's going to be an information of what the protocol should give. And there is missing discussion on application metadata and server assist. So server assist, I believe we've discussed previously a potential document that Raphael and I would write on server assist, because for those that were in New York for the interim in January, a few colleagues of mine, Raphael and I, also looked at the general architecture of a messaging infrastructure like this, and we could notice that there are many different aspects in terms of privacy that are affected by the actual infrastructure. So we don't want, like, this document will not be able to mandate anything, right, in terms of infrastructure, but it will be able to provide guidance, the server assist document, on maybe this solution is one possible solution to actually provide some reasonable privacy guarantees in your infrastructure. And I believe that we should do that after the architecture document is done, so that, at least it's stable, so that we can focus on federation and server assist after, like in Q1, probably in Q1, end of Q1, something like this. So yeah, that's it for me. I think after December 7, end of January sounds good. I don't know what you think, Sean and Nick, but it feels like pretty reasonable so that people don't have to work in the at Christmas and New Year's Eve, things like this. We can have the full January month. There is no urgency for that document anyway, but I think it's completely fair to get back to it right now. So yeah, expect an email from us around January 7th, something like this.
I think that works. Yeah, I mean, if you drop it like mid-December, no one's going to look at this till the beginning of the new year. So I think take your time and get it as close as possible, and then we'll let the death by 1,000 paper cuts happen via GitHub. I mean, it is what it is. The only thing I would add to your summary is that in terms of getting through the process, the only way that the follow-on process, to get through the ISG, is going to happen when we actually get the architecture and protocol document together and get them moving forward. So they'll probably go forward as a package. So I think it makes sense. So, all right, thank you very much. I believe I have granted Richard the screen.
Interesting. I do not see that permission myself.
Well, let me stop sharing my screen and see if I can now grant you. There we go.
There we go.
There we go.
All right. Is that visible?
And it's all of its bright pinkness.
Figured I'd use a little bit of visual energy to keep people awake across time zones. So this is going to be an update on the latest stuff on the protocol. It's going to be a blend of me and Raphael and Joel, all of whom have been looking at different aspects here. We're going to go through kind of what we've gotten done recently for folks who might not have been tracking along in detail. We got a couple of kind of major issues that Joel and Raphael are going to present. Fortunately, though they're significant and have some security implications, we have solutions that are pretty straightforward. So hopefully we can get those agreed here. And then if we have time, there's a couple of other minor stuff we might pull up on GitHub. I'll probably let Sean drive that part. So just diving into the highlights of recent stuff. One major change here is we've kind of improved how we do authentication on MLS plaintext. This is symmetric authentication of membership in the group and confirmation that a commit produced the right output. So confirmation that the recipient of a commit got the same output that the sender did. We had this confirmation tag hanging around for a while. We call it a tag now, moved it to the end so that it covers the signature as well. This is due to some work I think that Joel did with Daniel Yost and Marta Mlinarczyk, finding some issues with not covering that signature with the confirmation tag. So that simplifies the structure a little bit, simplifies that little select statement, and gets us some better security moving the confirmation tag down. That same group also noticed some issues that if you get an MLS plaintext, you get a signature on it on the left-hand side, but you don't get any authentication the signer is actually in the group until you except to the degree that you look up the verification key in your group tree. So in IBSI, you don't get any authentication that the sender knows the group secret. So if someone compromised the signing key but not the group secrets, then they could send these MLS plaintexts into the group. So this membership tag is just a MAC over everything preceding that authenticates that the sender of the MLS plaintext is a member of the group. So you can verify that before you do anything else with the message. And folks, by the way, should feel free to jump in if there's questions or comments here. Second thing to highlight, pre-shared keys, some really good work. Oh yeah.
Sorry. So it's so the problem you mentioned is actually only in the case where you don't encrypt the group preparation messages, right? Because in that, if you encrypt them, you have this authentication guarantee. Like it's a weak one, but it's you have it.
Yeah. So when you're encrypting, when you're sending MLS ciphertext on the wire, you get the authentication from the AEAD tag. So this is only for the case where MLS plaintext is what you're sending on the wire.
So so I remember that the phrasing is relatively relaxed right now in the document where we say we could, I think, send plain text and not encrypt them. Why? Do you still it's still reasonable?
Yeah, no, I think we are going to have use cases where we don't want to encrypt the handshake message, the MLS messages. And so I think it is important to continue to support that. And so that means we do have to kind of have a switch in the code because you're not going to have one of these membership tags for an MLS plaintext you've decrypted from this MLS ciphertext. But I think that's tolerable. It's not a huge amount of complexity.
Okay, thank you.
Sure, thanks. Second cool thing, thanks to some good work from Britta Hale and Conrad Kobrook, we have a new nice PSK framework. It works more or less like you'd expect. Someone who wants to add a PSK at an epoch sends out a proposal. You can get multiple of those proposals. So we have a scheme for combining multiple PSKs, and then they get injected into the key schedule as you're transitioning from the last epoch's init secret to the current epoch's epoch secret. Really, the novelty here is this proposal mechanism, and there's a corresponding signaling and welcome. I think this is kind of nice because it incorporates, it's kind of inspired by the TLS 1.3 design where you have PSK IDs and indicate PSKs, and incorporates some learnings from recent TLS and follow-on work to 1.3. So we have, I think one thing that has been done more recently in TLS is folks trying to introduce structured labels, so you can have specific labels that have internal structure for specific use cases. We're building that in from the start here. And I think Jonathan Hoyland has done some work on looking at, and also Stabila and the post-quantum folks looking at how you incorporate multiple PSKs or multiple entropy sources into the key schedule. So we're trying to capture all that good advice, good experience here, and incorporate it in round 1 of MLS. So that's pre-shared keys.
The only thing I would add there is that that was an exercise in patience on Britta and Conrad's part, that they thrust and parried and finally got the stuff done. So it was good to see the working group finally got this stuff incorporated.
Yeah, I owe them a massive mea culpa. I imposed a lot of delay and made them explain a bunch of stuff to me over and over again. But I think we ended up finally in a really good place. I appreciate their work here. One thing that came up is this is kind of a bit of a performance improvement. Before the sender of a proposal could send out a bunch of, the sender of a commit could send alongside that a bunch of proposals. And those proposals would each be individually signed in their own MLS plaintext. With this change, those proposals can just go directly in the commit. And so you save a lot of signature overhead, a lot of bandwidth overhead, and just send the proposals in line. Now, syntactically, what we wanted to preserve this property that we have a single proposals array, so it's clear what order the proposals are applied in. And so what we did was just change that array of proposals from being a list of references to proposals by hash to a list of proposal or references, so you can get the proposal by value or by reference. So we maintain that ordering, but we can indicate things by value or by reference. So this lets the committer just send along a bunch of stuff to apply as part of that commit. So you can imagine that if the committer wanted to say send us add a PSK as part of the commit, you just add that proposal to the end of the proposals vector. This simplifies, in particular, some of the external commit stuff, which Raphael will talk about in a moment. And this is kind of consistent with another idea that we had discussed earlier, that the kind of design principle that the way you extend the commit message is with new proposal types as opposed to having extensions in the commit message itself. So being able to put proposals directly in the commit message kind of makes clear that that's is consistent with that design principle. So it's basically mostly an optimization, less a security issue than these other things, but kind of nice from an implementation point of view. Some more focus things. Didn't pull these out onto one's major slides. One implication of the PSK work that was done is that we can do subgroups and re-init. So when you generate a subgroup, much like with, I think there's a nice analogy to TLS and resumption here, that in the key schedule produces resumption secrets, and then you can use those secrets to connect one group state to other group states. So branching is one instance of that, where you want to instantiate a subgroup or a related group. You can pull that resumption PSK out of the prior group and insert it into the subgroup or the branch group. And likewise, if you're going to reinitialize the group to say upgrade the Cypher suite or upgrade to a new protocol version, then you can tie the new group to the old group, again, using this resumption PSK. So that's kind of a nice application of the PSK work that was done. More optimization work on the third bullet here, the ratchet tree, for these cases where the delivery service might cache some of the tree information based on, say, plain text handshake messages. You know, if the server is following along, then it can provide the tree, and it doesn't need to be provided end-to-end in the welcome. So the welcome just provides a commitment to the tree, not the tree itself. It can optionally include the tree in an extension. Just a performance optimization there. More work from Britta and Conrad, this authentication secret derived from the key schedule. This provides kind of a, you know, in a lot of apps today, you have these security codes that people can compare to verify that they have the same crypto state. So here we can just, since we have this framework for deriving stuff off the key schedule, we can just derive another value off the key schedule that can be used for that purpose, so that you can compare this, and you're in the, if everyone in the group has the same authentication secret, then they know that they have exactly the same crypto state for that state of the group. And finally, there's been some concerns off and on about deniability. Sophia Celli did some review on this and proposed one change to improve compatibility with deniability going forward, which is to have a little bit of decoupling between the signing keys that are in the MLS transcript and the signing keys that are used for verifying messages. That landed after draft 10, but it's in master right now. Finally, a couple of efficiency improvements. We had this constant time add. I can't remember if that. Yeah, I think that was before we made the switch to proposal commit. We had constant time add where you could, you didn't have to change anything about the tree besides the leaf. We re-added that in draft 10. Forgetting the details of how that was done, but now adds can again be done in constant time. You don't have to. Oh, right. This is where we made the update path in a commit, the thing that takes you log to linear time to generate log to linear number of DH operations or chem operations. You can omit that path. You can not chem new entropy to the group if the only thing you were doing is adding, because everyone can just hash forward. So yeah, that gets us back to this notion of constant time add. Another optimization is that this update path in the commit used to encrypt new entropy to the entire group for the new epoch, including the people you just added, even though those people were getting the information from the welcome, not the commit. So the update path had useless encrypted secrets, and so we're omitting that now because they're just not necessary. And finally, we consolidated the key schedule a little bit. We used to have separate key derivation schemes for encrypting application messages versus encrypting handshake messages, and now we use the same secret tree for both of those. So you can delete a bunch of code that was managing that second key derivation scheme. So that's the review of what we have done recently. I think I'd like to pass it over to Joelle here to talk about some issues that he and his team discovered with the current hashing scheme we have for authenticating the tree. So Joel, you want to take over here?
Right. Just before we do that, so this is one of the issues that got called out during working group last call that we hadn't come to conclusion on. Was there anything else that you saw that came up that needs to be addressed?
I have not done I should do one more review of the mailing list, but I don't think I saw anything come up that needed to be addressed in the next draft.
Okay, excellent. Thank you. Sorry, Joel.
Joel, are you awake? See you in the participant list. You can click the microphone button to send audio.
While I have 2 seconds before Joel. There is one thing, Sean, that was mentioned multiple times, but we didn't really address, and we should definitely decide whether we are going to address it or not, is the application message truncation thing. So right now, an attacker can actually like arbitrarily remove messages at the end of the application messages.
Hello?
Without nobody actually knowing.
Joel,
And,
we do hear you.
We do hear you. And yeah, that's something we should discuss at some point. That's it. Because this is a remaining issue as well.
Yeah, that's a good point. We I think we did have issues for that, and I'm not sure why I may have erroneously closed them. But I think we should make a clear decision about that. Maybe we should have a call. I think we can see if we have time in this session, but if not, we should schedule a call in the next couple of weeks to close out on that. So Joel, one more time, we were hearing you before, but I think you turned your mic back off.
Okay.
I hear you now.
All right, good. I guess for some reason I can't hear anybody else when I talk, but I guess Sean gave me a thumbs up, which means I guess you can hear me. Okay. Well, I'll keep talking. But if there's a question, then Sean just wave and I'll turn off the sound so that I can actually hear other people. Okay. Thanks. Richard, I think you're still screen sharing, so do you think you could just go to the next slide? Genau, yeah, on further thought. That was it.
Oh.
All right. Okay. So, yeah, so this is basically what this concerns a feature called parent hash, which was originally introduced by Karthik and Benjamin when they pointed out that we need to be able to authenticate this tree in particular to give guarantees to people joining the group, right? And so what we did is, or what they did at the time, is they introduced this notion of a parent hash that hashes a part of the tree, and you end up with actually a sequence of parent hashes. Each node has its own parent hash to find, and then you put the last one down at the leaf every time you're doing an update path, and then you sign your entire leaf, and that includes the parent hash. And so in so doing, you're kind of authenticating certain stuff in the tree. But then there was some amount of debate around how exactly to define this parent hash. And at the time, there were then kind of two candidates, and we went with one, which hashed in less, because we were hoping it would maybe give us then a bit more deniability, because at the end of the day, you do sign this parent hash. So the more that it binds, the more you're sort of committing to aspects, properties of the group. And so we really revisited this, we being Daniel Jost and Marta Mularczyk, in our security review of MLS, and we found actually that this opens a class of attacks on MLS, the way that parent hash was defined in this minimal way. So we then proposed a PR that addresses this attack. So this is basically what I'm going to tell you about now. You can go to the next slide, please. Okay, so first, I'll tell you a little bit about what the attack is, because that's really going to motivate then the changes as well. So first, the way that the parent hash has been defined up till now, the sort of more minimal way of doing, we defined it in the past, is basically when you do an update path, so you're doing a commit, you're inserting a bunch of keys on your direct path, and you pretty much just hash back down to your leaf again. Only those HPKE public keys, right? So here on the top left, we've got a picture of a small group with Alice, Bob, and Charlie. Alice just did the most recent commit. That's why her direct path is marked blue. And so in particular, she would then hash first the root HPK public key that she put in, and then she'd hash in the parent node between Alice and Bob, and then she would at the end hash in her own. No, actually, I think she wouldn't even do that. She would just, just take that hash from the parent that includes the HPK key of the parent and the root, and then she put that at her leaf and she'd sign the whole thing. So the issue with this, kind of in a nutshell, is that it really doesn't tell you anything about who was told these secret keys that correspond to these HPK public keys. In other words, it makes it easy to, or possible to, create ratchet trees that violate the tree invariant, which leads to other bad things. Things like remove's not really working. As in, you think you removed somebody, but in reality, you didn't really remove them from the group. So here's an example of this, like a sort of pretty minimal example of how this attack would work. Bob is our attacker. So this is about insiders, all right? This attack would be mounted by an insider, somebody who's actually a participant in a legitimate group. And the legitimate group is at the top left. It contains Alice, Bob, and Charlie. Right, and Alice did the most recent commit, as we said. So here's what Bob does. Bob constructs a fake ratchet tree, like an artificial one. And so it's a fake group, and it's the top right ratchet tree. And then he invites Dave, who's the victim of this attack, to this ratchet tree, okay? So in other words, we now, one of the main thing to notice is that the way he constructed this tree is he took this direct path from Alice, which is a legit direct path, but then instead of putting himself where he was in the actual group, he switched out and put Charlie there, all right? And then he put himself in Charlie's spot, then creates this proposal to add Dave and commits to it. So you end up with this other ratchet tree over here, which looks legit because all the parent hashes still work out, right? In particular, you'll see, Alice's direct path has been maintained, so the signature at her leaf is going to verify for Dave. Same thing for Charlie. Bob can sign whatever he wants at his leaf. And so Dave is going to accept this welcome message and he's going to join this group. But of course, the attack where things have started to go wrong here is that Bob actually knows the HPK secret of Alice's parent, because in the real group, that's also on his direct path. But in this fake group, it looks like it's not. He doesn't know it. It's not on his direct path. So the next thing he does is he now, tells Dave, hey, look, I want to leave this group, and gets Dave to commit to removing Bob. So in the removal process, how does that work? Well, we blank Bob's, Dave announces this commitment, and then everybody being only Dave, because Alice and Charlie, aren't even aware of this group, will blank Bob's leaf key and then leaf key on his own path, which means it'll leave that node, Alice's parent node, intact. It'll leave the same HPKE key there, which Bob actually knows the secret to, and in particular, it even encrypts the root secret to that. So Bob can actually still decrypt this new root secret, this commit secret, and so he can compute the new key schedule for this new epoch, despite the fact that Dave thinks he's removed Bob from the tree. In other words, this turned into an attack where a removal did not actually have the effect we would expect. And the real problem here is that Bob was able to create a tree that violated the tree invariant. That was really the cause of this attack. So this is a whole class of attacks. You can do a couple different things with this, but this is the core. And the problem is that the signature at Alice's leaf, which includes this parent hash, doesn't authenticate enough. It doesn't bind in who Alice told each one of these new HPKE secrets to. So this is what we address with this PR. Next slide. So what's the intuition to fix here? I'm going to try to sort of, you know, lead the thought pattern here with what I've been saying, but the idea is basically we want to extend what goes into the parent hash so that it at least indirectly includes, for each node that's included in the parent hash, which other secrets, which other people received the secret key, right? We actually figured out that you can do this a little more indirectly, maybe for reasons of deniability or just simplicity, really. And it's enough to just include into the parent hash, every time you want to include an HPK public key of a node covered by a parent hash, you also include the resolution of the sibling on the co-path, right? So this exactly, that corresponds, so actually the HPK keys of this resolution, that corresponds exactly to the keys to which the HPK secret is being sent, right? So the set of public keys to which the parent's private key was encrypted to. So we augment the definition of parent hash with this. And otherwise we still keep the same things in, which is basically just all the new public keys that are being put into the tree on the direct path itself. Next slide, please. So here's a here's a pictorial depiction. You know, we have a small tree with three leaves, and this shows how you would compute parent hash if leaf 2 does a commit. All right, so that means leaf 2 has inserted new keys at node 1 and node 3, on node 2 as well. And so now it comes time to compute the parent hash. And the way it works is these red arrows indicate which values you're putting into the hash when you compute the parent hash at a node. Right, so you look at node 1, it's got this parent hash. Well, just as before, you include the public key of its parent, i.e. the root, and the parent hash value at the root, which is simply defined to be 0, by the way, for the root as a special case. But now, in addition, that's how things were up till now, but now in addition, you also include the resolution at node 4. All right? And that sort of binds into this parent hash value, not just the fact that, oh, this is the key at node 3, but also where did you send the secret key corresponding to that key? Where did the person at leaf 2 send it? They sent it to the resolution of node 4. Right, so that's the parent hash at node 1, and then the parent hash at node 2, you do the same thing recursively, right? So you include the public key and parent hash of node 1, and the resolution of, like, who was that sent to? Well, it was sent to the resolution of 0, which in particular is just the public key of 0 itself. So that's kind of the intuition of how it works. But of course, there's a little bit of a caveat here, which is if you see the name of the field in the data structure, we called it original sibling resolution. And that's because of the following thing. This is all clean and simple at the time of a commit. But of course, the whole point of these parent hashes is that 5 epochs later, when somebody joins the group, gets a welcome message, they want to verify these parent hashes, which means they should be recomputing the parent hashes, right? So you got to make sure that when you recompute the parent hash for a given node, say node 1, that you'll end up with the same value as the person, as did the person at the time who put it into the tree, namely the person at leaf 2. And in the meantime, in these intermittent 5 epochs, things can change in the tree, right? The tree is constantly changing at every epoch. So we have to make sure that the way we define this parent hash is invariant to any change to the tree, which will preserve the public key at node 1. Because the moment the public key at node 1 changes, we don't care about recomputing the same parent hash anymore. So it only has to be, this definition of parent hash only has to be invariant to changes of the tree that don't affect the public key at node 1. How can it be affected? Well, either node 1 can be blanked. Yep. Questions? So.
Yeah, sorry, Joel. Just a quick clarification here. I think this is, I haven't quite verified this to convince myself totally, but I think we're kind of okay here because the parent hashes are all sort of downward looking. They only incorporate the parent stuff, but they only are kind of visible lower in the tree. So here, for example, if 4 updated and overwrote nodes 4 and 3, then the parent hash in node 1 would no longer verify node 3, but that's already kind of accounted for in the validation algorithm. You would still be able to validate that the signature over the parent hash in node 2 verified the parent hash in node 1, which then would verify both the public key in node 1 and the resolution in node 0. So you still kind of have that invariance. So I actually think that we're pretty safe on this consistency count. Over.
Yeah, I mean, I agree. I think we are safe in the sense that it works out. I think the one case, so the most changes you make to the tree are either going to end up, blanking or ending up with a rekey, in which case we don't care about preserving the parent hash computation. The only case I think that's interesting is if you add unmerged leaves, right? So say we were now, we compute the parent hash at 1 because 2 just committed, right? And now the next thing that happens is a new person's added to the group as leaf 5, right? Technically, that means now that the resolution of node 4 has changed because there's a new unmerged leaf that gets included in the resolution, right? But it turns out that the same unmerged leaf is also going to be added as an unmerged leaf at 3. So the more general definition we have of parent hash, which collapses to the same thing on the commit moment, but later on may be important, this generalization is what you actually take is the resolution of the copath node, but then you take out the nodes which are unmerged at the parent. So when you're computing parent hash of 1, you take the resolution of 4 and you remove anything that's unmerged at 3. So now if you were to add a fifth leaf, yes, it gets added to the resolution of 4, but it would get removed again because it's also an unmerged leaf at 3. So you end up with the original resolution of 4 that you had at the time before 5 was added. So that's the only sort of tricky bit. And that's the way that it's actually defined, and that's why the field is called original sibling resolution. Yeah. So yeah, that's basically the definition. I don't know, is there another slide I forgot? No? Okay, good. Well then, I think if there's no questions, then I guess that's that.
So I think what I'd like to get here is any concerns people have with this general approach, because if folks are okay with this general scheme, don't have any of the concerns that we had back in January, then Joel and I can work out the details in the PR. Just want to make sure the group is okay with this general approach, kind of in concept. See Raphael and Benjamin.
Yeah, so I pretty much, anyway, I mean, the current status of the draft is that it's unsecure, right? And what Joel is bringing us is significantly stronger anyway. So I'm completely in favor of taking that right now. And anyway, we have the security analysis period so that we can validate that that's a good fix and things like this. So I don't see any reason to not take it in some sense.
Raphael, did you have a comment here, or you just queued up?
No, I was just getting ready for the next slides.
So the only comment I have is I think that I'm channeling Brendan McMillan here, is that we didn't make this change or really consider this earlier because there wasn't an attack, and so since Joel found it and we got a fix, I don't see a reason why we wouldn't include this. So basically just echoing what Benjamin said. So let's make it so.
Okay, cool. So I will work with Joel to figure out the nuances, but it'll be pretty much the solution. All right, so next, I wanted to pass over to Raphael to talk about the external commit mechanism that we added in draft 10 and one issue that we were resolving during last call. So, Raphael.
Yeah, thanks, Richard, for driving the slides. Yeah, so this is something that had been there for a while as a problem. So I can talk a little bit about the motivation here. We covered that extensively in the interim meetings, but I think it's good to repeat it here. So essentially in the architecture document, we say that at no point in time, two devices of the same group ever have to be online at the same time. And technically that's true. In that sense, the protocol is asynchronous. But when somebody wants to join, the problem was that one of the existing members had to send a welcome message to the new member in order for the new member to be able to join the group. And intuitively, that seems correct because you want the existing members to guard who gets access to the group. But it turns out that you don't have to rely on this welcome mechanism necessarily in order to keep the same logic. So there are cases where it would be very beneficial if members can just join without having to wait for an existing member to come online and issue a welcome message. For example, when you run MLS in a multi-device context where you have a concept of users that can each have several devices, and a user wants to add a device. And in that scenario, up until now, you would have to rely on one of the devices of that user or other users to be online in order to grant access to the group to the new device. But realistically is not how a lot of messaging apps work, for example. And so maybe just a quick overview. The way we decide on who gets to be in a group is actually decided by the authentication service. In the sense that it's this abstract layer that is out of scope for the protocol, and group members have to agree on a policy on who can join and who cannot. But if they all agree, all we need is a mechanism for the new joiner to actually be able to get into the group as quickly as possible. And in this particular example that I mentioned, where in a multi-device context, you just want to add another device, if on the authentication layer, you can clearly prove that that device belongs to the user and is a legitimate device, and there's actually no reason why that device couldn't join right away. So we never had a good solution for that, and then a while back we looked at how commits worked up until now, and there was a chance to actually modify it a little bit in the sense that this could be used by external joiners as well. So the way the policy is being applied is still the same. So before external commits, existing members could always reject ad proposal or ads that they think were actually not legitimate. And this remains true for external commits, and we're going to look at the details in a bit. I think you can go to the next slide, Richard. So how does it work in practice? What we need in order to issue an external commit is that the new joiner needs some information on the current group state. And all of that is generally speaking, public information. There are no secrets needed. Whether this should be available or not is for the specific application to decide. But we have the structure down on the left called public group state, where we have some of the parameters like the cipher suite that's being used for the group, obviously the group ID and the epoch we're in. We have a tree hash over the public tree, and there we can reuse the same mechanism we have for welcome messages now, where we can use an extension if we want to have the whole tree in there. There's the interim transcript hash, the extensions itself for the whole group. So all of that is very similar to what you have in the group info that is part of the welcome message. There's almost no difference. And then one thing we added was an HPKE public key that is essentially derived from the current key schedule. So this is a public key whose secret key is known to existing group members, and new journals can use that to chem something to that key. So in the first iteration, we didn't have that mechanism, and there essentially an external member would just send a commit secret like in a regular commit to all existing members, so that essentially they could have a shared secret there. Now, in the second iteration, I think Richard proposed that we have this external public key, and then the new joiner can also send an init secret to that key. So this is strictly more secure in the sense that before an attacker would only have to have one secret key in one of the intermediate nodes of the tree, one of the leaf nodes. Now the attacker also needs to know the actual group secret in order to break in. So this simply raises the bar on the security side here. So effectively what happens normally, there is this init secret that is the last output of the key schedule in every epoch, and that gets reused in the next epoch as a starting point for the key schedule. And so this init secret obviously is not known to the new joiner. So instead, the new joiner generates an init secret and kens it to this external public key, and that way existing members will receive it and can use it to calculate the secrets in the next epoch. And in that sense, aside from this mechanism where this external init secret is shared between the new joiner and existing members, the rest of the logic is pretty similar to how we currently do commits. And obviously here we reuse HPKE like we do everywhere else. Yeah, we can go to the next slide. So there's one weakness that we quickly discovered there with that external public key. So this initially was not authenticated at all, which is not great because that means that the delivery service can actually pick that key. It's not entirely clear what an attacker can do in that situation, but at the very least, the new joiner would be tricked to ken something, to a party that is actually not an existing member. So this is not good. So if you go to the next slide. There's also an obvious solution to that, which is not on Master currently. We're still debating on some of the details, but it looks pretty straightforward at this point. So all we need here is to have a signature over the whole public group state that includes the external public key. There was a bit of a debate on whether we should sign all of the fields in there. Some of them, we don't have a good reason to sign them, but we also want to be cautious here. So currently what we have in the PR, I think 433, is that all the fields are being signed. And that means that the delivery service cannot just simply swap out the external public key here. And so we have a signature here, and at the same time, we also have the parent hash, which is signed, what Joel just explained earlier. And these two signatures should be from the same member. So the last member to commit will calculate the parent hash, will update its own key package, include the parent hash as an extension, sign the whole thing, and then in addition to that, also produce this public group state and sign that. So the new member has to verify that both have been signed by the same member, and that way this public group state can be tied to the last commit. If you can go to the next slide, please. So there are a few other security considerations. So what changes here is that, as I mentioned earlier, the key schedule as such is discontinued because we don't carry over the init secret from one epoch to another. Instead, we take an init secret that comes from the new member. So we invert the logic here in the sense that previously we would send a secret to new members as part of the welcome message, inviting them to the group in that sense. And here it's a new member actually who's sending the init secret to the group. So one obvious downside of that is that the accumulated entropy in the group is lost at that point. So obviously we want random number generators to be as good as possible. But in addition to that, we since we keep on rehashing things between epochs, we also accumulate some more entropy, which is a good thing. So this takes a hit in that particular instance. So we didn't see any obvious attacks so far with that, but it's also pretty clear that we have slightly different security guarantees. Benjamin, did you have a comment on that?
Yeah, I was wondering what's happening with the transcript hash in that scenario. Isn't it actually hashed in somewhere in your design?
I think the transcript hash is hashed in, but it's public.
Yeah, the transcript hash is handled in exactly the same way as a normal commit. So I'm not sure I agree with the first 2 points here. With the HPKE-based scheme, the keys, the information in the key schedule and the entropy from the prior group carries forward via the external key pair, right? Since those are derived off the epoch secret, which has all of the entropy that the group has accumulated so far. The only difference is that that entropy, the new init secret that's derived by HPKE is also accessible to someone who holds the new joiners asymmetric key pair. So there's, I guess, some dilution that way, but you're still carrying forward the information that was in the group already. So I'm maybe a little less worried about these first 2 bullets than you are.
Okay, yeah, maybe I'm being too pessimistic here, but yeah, it sounds.
This is certainly something for the analysis to look at.
I mean, the status quo is that this does not violate any of the security guarantees we want to have in general. Like, you still have authenticity, confidentiality, FS and PCS, obviously. So it's going to be a matter of details, hopefully. And so, yeah, since this requires certain information to be public, like the whole public group state needs to be published with every epoch change. This mechanism is also entirely optional. So members can just not publish that, and therefore external commits become impossible because you don't have that public information. And even if they do publish it, existing members can also simply reject these external commits, which is something. So again, this is governed by the authentication service. So whether a member is allowed to enter a group via an external commit is for existing members to decide. If they, according to their policy, they come to the conclusion that the new member should not enter the group, they simply completely reject that external commit and merrily continue as before. So we haven't changed the access control as such. So I think that concludes that part. Are there any questions?
So this is Richard. I am totally on board with this. I think so the change proposal here is to add the signing. I think that makes sense. We already merged the external commit stuff, which I think is also a good idea. So I think the signing is a good idea. I think, Raphael, you mentioned one thing that I don't think I quite agree with. You mentioned that the signer of the public group state should be the same as the last committer. Well, I agree that's the obvious implementation strategy. Like, if you're implementing this in a whole system, you should probably just have the, whenever someone sends a commit, they also send an updated public group state. But I don't think that necessarily needs to be the case. I think you could allow for other, any group member to sign, even if they're not the latest committer.
Yeah, possibly, yes. The question is, how would that work in practice? Because as you say, the committer is the one being active when you change epochs. So this would require another group member to be active at the same time, because obviously these things need to be synced. At the very least, the epoch member is in the public group state. So this gets stale immediately after you change epochs. I don't know, I'd have to think about it. I don't have any obvious arguments against it, other than I think it's not something that would be realistic in a number of cases. But if we can relax the what we want to achieve here, then sure, why not?
Yeah. Jonathan, I see you're making some comments in the chat. Did you want to bring anything forward here? Jonathan Hoyland?
I was just trying to understand what the scheme means, what it's supposed to be doing.
So you're asking if the new joiner can evict people from the group before anyone processes the external commit. So the external commit works exactly like current commits. So it can reference actually any proposal that's out there, or it can create new proposals. It can also have the proposals by value, as Richard explained before. So a new joiner could actually evict people as part of that commit. However, we would have to see, because the evicted members, at the very least, they know the secret to the public key, the group public key. So this is not something you can take back because this is calculated ahead of time. We would have to see if the eviction is as good as it should be. It's an interesting question.
But yeah, I think that's something that might not be immediately obvious to folks about this external commit. It is actually a fairly powerful mechanism in that you can include the person that's adding cannot just they need to add themselves. That's required for the commit to be valid. But in addition to adding themselves, they can do any other group operation. So they can add other people. They can remove people from the group. They can add PSKs. They can request the group be reinitialized even. So there's a full power commit. Now, personally, I think that's a feature and not a bug. I think there's some cool stuff you could do with this. The one I put in the chat is that you could, one of the concerns that have been raised, like what if someone loses their state and need to resync? Well, this gives you a resync operation based on the public group state, because you can now make an external commit that adds your new version of you, re-adds you to the group, and removes your old appearance at the same time. So you get a resync operation for free by virtue of adding this external thing. So personally, I think this is a feature, not a bug. But if other people have concerns about the power of this feature, I think that there may be some things lurking there that I'm not thinking of.
I think it's great to be powerful, but that just means we're going to have more security review of it to see whether it's the power for good or the power for bad. So I think that it's good that we've got a security review time built in. So I mean, it sounds like we should go ahead and merge. We should go ahead and merge this stuff and then basically see what happens.
Now that I had a minute to think about Jonathan's question, so I think evicting people still works because you change the tree. So if you have a remove proposal, you change the tree first, and then the new member would not send the commit secret to people who have been evicted. So essentially, the eviction would work. And I think there was also a previous question whether the new joiner can send messages or not. So the whole idea behind this mechanism is that as long as this public group state is available to the new joiner can get started immediately with that by issuing the external commit and kemming the external init secret to the group, and then just apply this commit to its own state, and then the new member can immediately start sending messages. So it's immediately part of the group in that sense. The only question is if other members will agree with that external commit. But this is something we have to assume they will do, otherwise there was no point in doing it in the first place. So if they will agree with that external commit, then the new joiner is immediately a regular group member after having issued and applied the external commit. There's no difference anymore between the new joiner and other members. And as Richard pointed out, on the motivation side, I think this simply might make MLS way more accessible in scenarios where you don't want to have this constraint that two devices have to be online one after each other, and have a dramatic effect on or impact on where MLS is going to be used.
Okay. I think the next slide is to move to the GitHub issues, Richard.
Well, so same question here as for the last one. In terms of the PR, so this is kind of last call for folks to express concerns about the signing of the public group state. So unless folks object here, I think we'll go ahead and get that one merged. All right, hearing nothing. I think at this point, all I had left was there's a couple of other more minor PRs on GitHub. If the chairs wanted to go through those, we could. But other than that, it's further down the timeline that Sean elaborated.
All right, let me know where you want me to go, issues or pull requests.
Why don't we go to pull requests? So we've discussed, let's see, we've discussed already number 433 and 435 and 436 kind of go together. Those are the ones that we discussed with Joel. We can just look at 438 if you want to. That's mainly just removing some open issues that have been flagged earlier that I think are no longer really open. Oh, I see Raphael commented on one thing. Right. Okay. Yeah. So Raphael's saying here that we should continue to document the fact that you could have a malformed update path that encrypts one secret to some people and another secret to other people. This, for folks who might not have been tracking, is something we've known for a long time and is not really solvable with the tools we have that exist today. So yeah, Raphael, I think that's a good point. We should add that to the security considerations. I'll update the PR to do that.
Yeah, that sounds good. It doesn't have to be an open issue.
All right. So that's it.
No, there's one more at the top there.
So, I could blow past it. Sorry. Sorry, not here. You meant here. It's
oh, sorry. Yeah.
Identity should be unique per group. Okay.
Yeah. Yeah, so here I think we might have some disagreement among folks. So I think the premise here is to require that each member in the group have a distinct identity in their credential. Yeah. So I don't know. Maybe
Yeah, I think this is a mix of two things. In the sense that there are some inconsistencies in the language of the protocol there, and this is why this was started. And then it opened up some questions of what we really want here.
Yeah, I think we should. This might need a little bit more discussion in the PR to get to what the issue is, because like I'm a little concerned here that there are cases where you want to have multiple appearances of the same identity, for example, for multiple devices. And you might have multiple credentials with the same identity. And so I'm worried when I see things like the requirement here that and multiple ads for the same identity would get ignored, or some of them would get ignored.
Yeah,
But
I
yeah,
think
maybe-
it's like
maybe
you say, we
there's
should discuss
some-
it a little more. Maybe we can add that to the other subject we wanted to discuss. I think, was it the tree signing? We said we.
No, the other one was transcript truncation.
Yes, exactly.
method.
Sorry. So yeah,
Application.
maybe we can combine that and discuss that over a call.
Yeah. All right. So Sean, it sounds like our chairs. It sounds like maybe we should have a call in a couple weeks to close out these last two issues. And then, and obviously we can have some discussion in the PR in the meantime. And then we'll issue draft 11 and start our feature freeze and analysis period.
I mean, just to be clear, right? You're going to drop 11 before that happens, and then we'll do the
Yeah.
freeze, right?
Yes. So just to be clear, I think the timeline I had in mind was have a call to discuss these last issues. Then once we've resolved them, then drop 11, then start the feature freeze.
So we're probably
draft
looking at
11 will be the analysis target.
Yep. So I think what we're saying is that we're looking to have another interim, possibly the first week of December. I haven't looked at my calendar. I know what's going on, and we'll do a poll to try to make sure that we can get participation from all those interested.
Yep. The week after Thanksgiving in U.S. terms. All right,
Raphael.
No, that sounds good.
I guess the other thing we could talk about is implementation and interop planning. But I don't know that we've got all the right folks on here.
Right. Well, I mean, I think what we should do is I would like to make sure that we set up a wiki in the GitHub repo for implementations, and so that we can set up an interoperability matrix, and then basically try to blow through things. And it would be good if you and say Raphael and Benjamin and maybe Britta, can figure out like if there's some way to like figure out the right order of things to test to make sure that at the end you end up with an implementation that works. I don't know if that's necessary, but I just have this vision that like if you're trying to aid people that are coming into the stuff cold, that it might be good to have a guide. Yeah,
and actually, it if someone in the group in the meeting was more new to this and wanted to get familiar with stuff, that might be a way to contribute, is to help think through what some of those cases are that you'd want to test out, based on your reading of the spec. So help would be welcome there.
Yeah, I second that. And then we need to figure out a way how to really test interop, because I think right now the status quo is that initially Richard started an implementation in C++, which is quite advanced by now, and I also saw other people contributing. The same is true on my side. There's one in Rust, which is close to draft 10 now. Still a few things to catch up. And then we need to see how we can actually interrupt between at least these two implementations. We already briefly discussed the possibility of having a server there. This is something we're gonna continue to work on, Richard. So it'll also be in the open, so we can maybe see if we can reuse that. Or
yeah, I think we tried to do a more test vector based approach a little while ago. I think that's, having played with that a bit, I think it might be a little challenging to get that exactly right. I think we are going to need, we might be able to do some degree of testing that way, just to verify basic functions like the crypto primitives and some of the message serialization. But to really get the behavioral interop, I think we're going to need to do some live testing via a server. So we'll probably define some little, JSON over HTTP and WebSockets protocol to shove things back and forth.
Yeah, exactly. I mean, just for context, test vectors are complicated because of all the entropy that is being injected all the time. So in order to get that out of the way, you have to make a lot of modification to actual implementation. I think we should get there, at least on our side with OpenMLS. We're going to try and get there at some point, because I think TLS also has done that in the past. It's a good thing to have, but it's not exactly a low-hanging fruit. So the test vectors we had in the past was for some of the tree math and, like you said, some of the serialization. Well, they're completely inaccurate now, because I think they were referencing something between draft 1 and 4. We can try and get that back, of course, but I fully agree that we should try and interrupt, see how that goes, and then do full test vectors as a second step.
Why can't you actually replace your random calls to your random function to return zeros all the time?
Yeah, that's one of the things you can do, of course.
You could do that in principle, but I really do not like adding that to production code. Code that might end up in production.
Okay, I see.
It's something you want to do behind a feature flag or something. It's not that straightforward in practical terms.
Okay.
I mean, so I hope that as we declare an analysis draft, that will encourage more people to show up with implementations, because then they'll have a warmer, fuzzier sense that the draft is not going to change so much. But we'll see.
So yeah, I think that's the main point, at least for me and Karthik, because we are doing the implementation and the code are the same thing for us, right? So we are proving something on the code. So we don't want to redo proofs like gazillions of times. But yeah, I'm pretty sure we'll have something reasonable in the next few months during the analysis part. But that also depends on Karthik, not only on me. So.
All right. Well, unless anybody has anything else, I mean, at some point, to be honest, right, we're going to have to go back and lean on a mod to do finish the Federation draft or abandon it, and we're going to need to do the server assist draft and get working on that. But I think the key point is getting the protocol done, get the analysis started, do the architecture draft, and then look to pick up the other pieces.
Should we submit the first version of the server assist draft just so that it's actually public and under the...
Yeah, absolutely. Go ahead and submit it as an individual submission. Whatever, draft dash, whatever last name you're going to use, and just go ahead and put it up as soon as possible. And we can get people to start reviewing it. And if we have time and then there's people that have reviewed it, we can adopt it whenever.
That could be a good place to do an informative proposal API for the server part. If people want to interrupt, we should document that somewhere. I'm wondering if it's not worth doing an exemplary API, like a proposal API in there. Not sure.
I'll put it in the chat right now. It's a stub right now, and we haven't looked at it in a while. But that's what we can get started with.
Yeah, I mean, the nice thing here is that don't feel like you got to hold back. If you got a good idea, feel free to submit a draft, or if you think it's not really drafted material and you want to put it up on the GitHub repo, we can figure out a way to get that done too.
Speaking of drafts, there's one a bit farther afield. I just posted a link in the chat. Folks are already talking about how to use MLS2 key S-frame, which is another working group for encrypting media. So that might be of interest to folks.
All right, I think that's going once, going twice. Sold. Thank you for participating today, or whatever hour it was in your locale. Thank you again for taking notes. Sorry, Nick, I didn't want to jump on you there.
Thanking folks for taking notes and participating so far. I think we've made a lot of progress and looking forward to the new draft.
Great. All right. Ciao, folks.
Bye, take care, everyone.
Thanks. Bye, everyone.